All right, we have over here a problem, which I already started, but we have a golf ball that is being shot at a bowling ball, which is stationary. The golf ball does have some kind of velocity. So we're just assuming here, plain old assuming, okay? Maybe I should delete that. I should probably remove this. Okay, I will. This was from a previous video attempt, so we're just gonna go ahead and remove that. Okay. So first things first, we need to establish that this bowling ball, even though it's stationary, it's 111 times greater in mass compared to the golf ball. Okay. If you guys got this question on an exam, I'd actually be very sorry for you guys because that is sad. How are you supposed to know that type of stuff in an exam? You're not. Anyways, let us suppose that that golf ball was going at 5 meters per second. Very small, I know, okay? We multiply 5 meters per second by 0.045. We get, what do we get? We get 0.225 is equal to mg dot vfg plus, and then what's 0.045 times 111? That is 4.995 times, and we use this equation right here, which I don't know if you guys can see my cursor, but we use this equation right here, and we get the answer that our final velocity for the bowling ball will be 0.0892. Okay, now simple rearranging. So we multiply 4.995 by 0.0892. We get, this is equal to 0.44554. I actually missed a 5, but that's, who cares? Okay, guys, this works one time, it doesn't work the next. That's fine. All right, we add over here 0.045 times VFG is equal to 0.225. We do 0.225 minus, because remember now these two are in the positive direction because the bowling ball starts moving this way and the golf ball originally was moving this way. The golf ball in the second iteration starts moving this way, right? Because that we're considering negative, and this we're considering positive, and this we're considering positive. So if we do that, then we do 0.225, we rearrange this, we take it to the other side, so minus 0.4455, we get negative 0.2205 is equal to 0.045 times VFG, okay? And then we divide that number by 0.045. What do we get? We get negative 4.9 is equal to VFG, okay? That's our velocity. Already this velocity, if you take a look at it, amounts greater than our original velocity for the bowling ball. So now if we take the kinetic energy for both, which I think I'm going to do with this pink, okay, let's do kinetic energy of the golf ball first, okay? We're doing, what's kinetic energy? It's 1/2 mv squared. Our v is 4.9, right, squared. So that's 24.01, okay? So 1/2 0.045, 24.01. We multiply that, so times 0.045, divide that by 2, we get 0.540225. Okay, let's find the kinetic energy, Ke, of the bowling ball. Okay, so that's 1/2 m. What's our velocity? Let's start off with that, 0.0892. Okay, we square that, 0.0892 squared, which will give us a very small number, but I'm going to write it out anyways. This is 1/2, 4.995, right? 4.995 times 7.95664 times 10 to the negative 3, okay? So it's tiny. We multiply that by 4.995, divide that by 2, and you know what we get? 0.019871708. Okay? And you might not believe me in terms of the numbers. Why does this have more kinetic energy if the mass is so much greater? Well, the mass doesn't really matter here because we're looking specifically at velocity the most, because velocity is the value that we square, right? The velocity is a value that gets multiplied endlessly. Because if you think about it, these two velocities over here, these two momentum pieces, which are mass and velocity, if you take out the square, they're going to equal each other. One of them is going to be negative and the other one's going to be positive. Unless if the two balls are going the same direction, which they're not, right? So if you take out the squared, these two are the exact same. So for these two, let's say if this was 0 or if this was any number, for them to add up, they have to be relatively the same. So if you think about it, because one of them has such a great amount of mass, the other one, which has a very small amount of mass, right? Because this will multiply out to be much bigger than this times that, right? If they had the same velocity, this momentum would still be much less, which, because they don't have the same velocity and we know they somehow have to even out, this velocity has to be quite big. And the velocity is the one aspect that changes from momentum, the equation for momentum, to the equation of energy, right? Where it's getting squared. So when you square a number that is a decimal, right? Our number over here was a whole number, or, well, I guess somewhat whole. It's negative 4.9. At least it has some kind of whole number to it. This one over here was already a decimal. When you square decimals, they just get exponentially smaller. And that's why this kinetic energy is so much smaller than this one. And that solves it. The golf ball has more velocity, exhibit A. And because it has more velocity, we know it has to have more kinetic energy. And that's it. That's all there is to it.